Hi everybody, Kent Marts from Explore Scientific, and I can hear myself in my ears, so I know I'm on. Welcome to Friday. Today is Focus on Astrophotography here on Amazon Live. Thanks for joining us for a Friday where we're going to talk about a field of amateur astronomy that is expanding rapidly. And I'm taking my ears out, Paul, because I keep hearing myself. Okay, so.
Should have probably tested it first.
Yeah, I know. That's the way it goes. We didn't test this before. Trying to do it in-house here, but that's the way it goes. All right. So everybody lives under light polluted skies. Like 80% of the country can't see the Milky Way. But you can take pictures of the Milky Way. And how do you do it? Well, you do it if you already have a digital camera, a single lens reflex camera like this one. This is a 10 or 12-year-old Canon. It's a 5D Mark III. It's a good camera for when it was built, but you know, it's an older camera now, and cameras get old, and that's the way it goes. So if you've got a camera and a tripod, you're ready to start taking pictures of wide field stuff. Now, you don't want to try to do it right now because why? It's a full moon tonight, and doing it on a full moon is not a good way to take pictures of things up in the sky. This will be interesting to see after yesterday's reindeer games. Yes, Wade, it was great fun to play Stump the Chumps. And of course, Annie was asking convoluted questions and, you know, jokes. And how do you tell some of those? So, hi everybody, welcome to Amazon Live. I'm Kent Marts. Here on the Amazon Live broadcast we have today. Thanks for joining us. We're going to be talking about astrophotography, and specifically an area in amateur astronomy is astrophotography, and it is a ever-growing popular way to participate in amateur astronomy. The dad frequency says yellow. Well, yellow back to you, the dad frequency. We're going to talk about amateur astronomy and specifically astrophotography. Oh no, is Andy Scarborough running the equipment again? Nope, that would be Paul attempting to run the equipment. He's been working from home. He's here today, and it actually worked better from home than it did working here in the studio. Paul, you can say something?
I'm not on.
Oh, okay. The dad, okay, this is what I need to post attention to. He has.
Ask him if that thumbnail is the movie Rubber.
Paul wants to know if your thumbnail is from the movie Rubber. I hope that is not a reference I wish I hadn't referred to.
No, it's a tire movie.
Oh, it's a tire movie. All right, so let's talk about astrophotography just a little bit. If you have a digital single lens reflex camera, DSLR, you're ready to start doing some astrophotography. How do you do it? If you have a tripod, you just set the camera up on the tripod. You wait 6 or 7 days until the full moon is gone and you have a dark night. You point the camera towards the southwest because that's where the Milky Way is right now. And what do? You simply set your shutter speed or your ISO at, say, 1000. Set your shutter speed for 10 seconds and take a picture. The individual pictures are not going to look much. Set the aperture wide open or one stop down from wide open. So, you know, f5.6, something like that. And just take a picture with your wide angle lens that you have and just experiment. And you just keep changing things till you find out what works. He says, no, it's actually my car's tread. There you go, Paul.
You should watch the movie. It's dumb.
He said, you now need to watch the movie because it's dumb. There you go. But is it Dumb and Dumber?
No, it's a horror movie where a tire kills people.
It's a horror movie where a sentient tire kills people.
No rim, just the tire.
No rim, just the tire. It just runs them down and yeah. So anyway, all right. So you've got a digital DSLR. You're taking pictures of the night sky. You're starting to get some. Now, you're going to have to put them in a program and you're going to have to manipulate them. You're going to have to open them up. You're going to have to learn because each individual picture won't look like much. But once you manipulate them some, you open them up, you brighten them up, you play with the adjustments a little bit, you can learn how to do that. You know, and there's tutorials out there that you can find as well. that will teach you how to do some things. So once you start getting that and you start liking what you're doing, you can only go for a certain period of time, and then the sky is going to move enough to where you're going to get blur in your camera. There's this rule called the rule of 500. So if you take the focal length of your lens that you're going to be shooting at, in this case, it could be 24 millimeters. You divide 500 by 24, and that tells you how many seconds you'll be able to leave the shutter open and get no or very, very minimal blur. So at 24 millimeters, that's going to be, call it 25, it's going to go in 104 times. You could take 20-second exposure with this lens, and you'll be able to get pictures of the sky that aren't blurred. If I zoom this all the way out to 105, well, 105 will go into 500, we'll just say 5 times, right? So I'll be able to take up exposure of 5 seconds with this lens at 105 millimeters to get a picture. So obviously the easiest way to start is the widest angle you have on your lens, and then on your camera lens, and then use the rule of 500 to determine how long to go. And just take pictures. Take some, change the ISO rating, jump it up to 1200, then 1600, then 2000, and write notes. First 5 exposures were this way, second 5 exposures were this way. And by doing that, you're going to conduct a little bit of science, and you're going to find out which ones make the pictures look the best after you manipulate them. But you're going to get to a certain point that you want to up your game a little bit. How do you do that? You do that by putting the camera on a tripod and mount that's designed for astrophotography. Like right here in front of me, the IEXOS 100. It is a go-to tracker mount. Go-to meaning you can use a computer, in this case a tablet, to tell it where to go after you do some things. And polar aligning one of these mounts is the important part of the process. Now, by polar align, I mean getting this axis right here, and this axis goes round and round, just like the Earth goes around and around on its axis, so too does this mount. That polar axis right here is designed to mimic the rotational axis of the Earth. So what do? If you're at latitude 36 north, you simply set 36 over here on the dial, right here. You can see it's got a gauge on it. Right there, you can see it. Right there, you set it to 36. You point it north. How do you know where north is? You can use a magnetic compass, or in many towns, the streets line up with true north. If you have a smartphone, you can use your smartphone for it. Most smartphones have a compass. Just go under the settings of the compass and tell it to use true north, which means it's not using magnetic north. Magnetic north, especially if you live on the coasts of the United States or the coast of Canada, is way, way off, 15, 18, some places around the world off 20, 25 degrees as much of, meaning the compass is going to point over here at magnetic north, but true north is over here. You have to account for that difference, okay? And you can just stand back, line it up. I use a stick or a broom before. Sometimes, if I got somebody to help me, I'd literally just stand back with the compass and tell them rotate a little bit left or right until it's lined up. Once that's done, off you go. So how do you get a camera on here? We have a device, the DSLR camera adapter right here. It's over in the carousel today. You'll be able to find it, and you can put this on the bottom of your camera. I'll show you how this attaches though. This is just like the attachment that you get on a telescope. It's called a dovetail, and you can just simply put it in there, and just like a telescope is going to mount to this, you can also do it with this device right here. So I'm going to go ahead and screw it in to the bottom of the 1/4 to 20 nut. The 1/4 to 20, it's actually a bolt, I guess. That'd be a nut down in the camera. I'm going to tighten up the screw, which is the bolt part. And I always like to do this with a screwdriver or a coin, but I didn't bring one with me, so I'm just going to do it with my hand. It has a little bail, like a paint can handle, and I'm just going to get it as tight as I can with my hands. I always turn it a little bit. Got it as tight as I can get it. I'm going to tighten it down a little bit more. And now, here we go. We're going to slide this in to the camera adapter. I know it's going to balance about right there. We want to get it balanced. Although the counterweights are set way down here at the bottom. I'm going to go ahead and show you how this balances. Always use both of the screws that hold things in. It creates a jam situation and helps keep it from coming out. And there we go. Got it in there. Tighten it up. Don't have to go crazy on it, but you want it nice and tight. Now then, I'm going to make sure the camera and the mount are pointed north and squared up to the mount right there. Let's just see how close to balance this is. Not close at all, so let's move the counterweights up. Real simple process. It's really easy to do. It's some things you got to learn, but like any good hobby, you have to put some time into it. And that's pretty good. I want it a little bit counterweight heavy because that keeps the teeth in the gear train engaged. There we go, just a little bit heavy. Return that. And from previous experience, I know this is close enough to be in balance. So the Exos 100 can be controlled with a tablet, and this is an Apple tablet, but you can also use an Android tablet. And right now, they have to be a tablet. Won't run on a smartphone yet. We're working on an app for that. I'm going to turn this around, and just to see if I can do this upside down here for you, I'm going to double tap it to make sure that there's nothing running in the background. There's not. So I'm going to tap the settings. I'm going to tap Wi-Fi. I'm going to tap Wi-Fi. And it's going to come up, and you'll see PMC8 pop up. Is it turned on? No. Helps if we turn the battery on. So we'll see PMC8 pop up here in just a second. Paul, can you see that all right? So I'm going to turn it off and then back on. That'll make it ping everything. It'll pop up here in just a second as soon as it does its thing. Sir? Pekka says hello. I'm trying to get my earpiece in. Yeah, I'm still hearing myself. So, of course, there it is. Oh, I didn't notice it. This already knows it's been hooked up to this PMC8, so it hooked up itself. So I'm going to go back here, and I'm going to launch Explore Stars. Now, we know Explore Stars is not running in the background. If it's running in the background, when you launch it, double tap, there it is. You simply flick it away. Right? Now you know it's not running in the background, so I'm going to relaunch it. Now then, just to test to see if it's connected up, right here you can see it's got what looks like a little compass rose. That is a virtual joystick, and there we go. You can hear it and see it. The noise canceling mic may cancel that out. It makes a sound, and no, we can't turn that sound off. That's the sound of what the motors and the circuit boards make when they're running. So here we go. So let's go to menu. Let's go to catalog. Let's go to solar. Doesn't like to be upside down. And we're going to hit slew to object. Now then, there we go. And off we go. Get the go-to to go. There we go. Off to the sun we go. Now then, if we were doing this in real life, not in the studio, because we're going to the sun, I would want to make sure I have a solar safe filter ready to go on top of it, because that solar safe filter will keep the sun from frying your work. So Paul's going to sneak in here and hand me a sun catcher, and we're just going to put this, and hand me the other one, please. This one's got too small.
That's the only one you're going to get.
There's another one over there. There was.
Yeah, but these are special.
Okay, well,
They're high.
yeah, I know which. This won't fit on here. The other ones will.
Doesn't matter.
This is going to go on here just like this. This one's not got the foam cut out of it, right? You cut that foam to fit.
It'll actually fit on that.
This one won't. There's no way.
You take the thing off the front of the camera.
Still don't think it's going to fit, Paul. It's not going to fit, Paul. Hadn't been cut down.
It's been cut down.
And Paul's going to ruin my set.
Well,
It won't fit.
complaining.
It won't fit. Just give me the other one.
Stop.
Paul's going to prove he's going to break it and make it fit.
It actually goes on this camera right here. that's what it's got.
Yeah, it fits on that camera right there perfectly, but they won't be able to see anything. But you get the idea. I could be pointing at anything right now. So as you noticed, when Paul moved the camera, it turned a little bit. That's one thing you got to make sure that you have this all tight, because you don't want it in the middle of your session to do that. I didn't put it super tight because I was using my fingers. I could use a quarter or something and tighten it down, and it's not going to move at that point. So as you can see,
Why did you do that?
as you can see,
Why?
why not?
I'm trying to solve that.
Well, I'll pick it back up in a minute. Can't get it on the camera. So as you can see, now we've gone to the sun. If we did a good job getting it polar aligned north and south, and if you live in the southern hemisphere, it's the same process. The tablet knows you load GPS, and so it knows where you are, and it just works. So it goes to the sun, and if you had a good polar alignment, you start out with everything square and pointed where it's supposed to, camera pointing due north, counterweight shaft straight down, bingo, off you go, and
You want to play the polar alignment video?
sure, play the polar alignment video. Here's a video on how to do polar alignment using a household object. You know, you'd use a stick or a board or even something more unique than that. So here we are. Paul, I know this one. Of the earth. And to do that, we're going to start with the tripod. We're going to decide which one of these legs is going to point north, and we're going to set the tripod down so that leg is pointed north. First thing I'm going to do is use a level to make sure my tripod is level. So if it's tipped one side or the other, that's going to cause your polar alignment to not be accurate. So we're going to use a level for that purpose. Then we're going to take a compass, and just to make sure that I've got it pointed north, I'm going to use the compass, line up, and go, yep, that looks like it's pointed north. So here's what I'm going to do now. And this is where the broom comes in. The broom becomes a measurement device, if you will. So I'm going to put the broom on the ground with the tip of it right against the north leg of the tripod. And I'm going to back away, and I'm going to use the compass. I'm going to close one eye. And I'm going to use the compass to make sure that the broom is lined up with north, right? And so I can tell I'm off just a little bit. So I'm going to move the tripod just a little bit, and I'm going to turn the broom. And the broom is what I'm seeing that line with to line up. So closing one eye. Now my broom is lined up perfectly to magnetic north. Right here is we're going to talk about something called magnetic declination. The magnetic north is not true north. The difference between true north and magnetic north can be off by as much as 15 or 16 degrees if you live on the east coast or west coast of the United States. Around the world, it varies. And you have to figure out what that is for where you live. Because if you point at magnetic north, you're not going to be pointing at true north. You could be off by 15 degrees. Your go-to will never be accurate. So for this system to work, you have to know what that offset is and be able to program that into your compass. We're going to provide a link to a website and a video that talks about that a whole lot more. Now, we're going to make sure that the tripod is not angled wrong. I'm going to use a small tape measure, and we're simply going to come down here and being careful not to move the broom, and I'm going to measure the distance from the tripod leg to the center of the broom. That is 470 centimeters. That way, it is 470, a little, I'm going to call that good. Actually, I'm going to move the tripod a couple of millimeters, just like that. So now, we know that we're lined up true north with that leg, and these two legs are the equal distance from right here. So it's not pushed that way or that way. So now that we have the tripod with a good alignment to the north, we have to put the head on the mount. And that's going to entail this. We're going to be very careful when we do this. because we don't want to move the tripod. We're going to put it on and simply screw on the polar head just like this. Remembering everything's going to the north. Now if you're in the southern hemisphere, you're going to do the same thing. You can do the same exact same in the southern hemisphere. Because it's not polar, it's polar alignment, we just don't use the star Polaris, which we're not using here. This is really good if you can't see Polaris, or if it's daytime and you want to do some solar viewing with a solar safe filter. So the last step of this process is to check the scale of your altitude, right? So we live at 36 degrees north, and I am going to turn the altitude until it gets to 36 degrees north. I'm going to stop, and that's it. With this system, using a broom, a compass, and a tape measure, you can achieve a good, decent starting polar alignment. Personally, I've used this, and I've got an amazingly close polar alignment. There's ways you can use to refine your polar alignment, specifically drift alignment, but it all starts with a good polar alignment. You can do this in the daytime. You can do this in the nighttime if you can't see Polaris. It works all the time. It's a good way to get started learning the process of polar alignment. Isn't that great? I hope you've enjoyed this video. For Explore Scientific, I'm Kent Marts. Get out there and start doing astronomy. And keep looking up. That's how you can use a broom to clean up your polar alignment. It actually works really well. Sometimes you can get dead on, sometimes you get real close, sometimes you can just get close. As you can see, I now have a solar filter on here that shows how the solar filter goes on the front of your device. It goes on the front where the light comes in. If it's telescope, it goes on the front. If it goes on this telescope right here, it goes on the front of the telescope, not back here, not back here. This stops the light from ever going into your telescope where it's going to fry the insides of your telescope, cook the sensor in your camera, whatever. This is a solar safe filter. It's a sun catcher. Comes in a variety of sizes. You can order them right here on Amazon Live. They should be over in the carousel right now. You can click on one, find the one that fits. If you don't know what's going to fit your camera or telescope, real simple matter. Click the, go to the Explore Scientific store here on Amazon, and you can click Contact the Seller. Noah over in the Brain Center is going to get that message. Noah says hi. Going to get that message, and he's going to help you figure out exactly which one you need to order right here off of Amazon. So you've got a solar filter. You've used your camera. You've learned to use your telephoto. You want to up your game a little bit. How do you do it? Well, you go to a telescope. Now, this is going to fit on here just like the camera did, right? Because it has a dovetail. So we're going to take the camera off of here, and we're going to attach the telescope to the IXOS 100. Slide it in. Come down, and I know exactly where the balance point is because I've done this enough. Close enough to the exact point. There we go. Now then, how do you attach your camera to this? Well, I will show you how to do it. It's real easy to do. I'm going to have to move this a little bit towards the middle so you get how to see it. Turn that like that. So I'm going to loosen the clutch. I'm going to turn the telescope this way so you can see it. I'm going to tighten that clutch down again so it'll stay where I want it. All right. These are clutches, not locks, designed that way. So I'm going to remove the diagonal. This is where you would put your eyepiece if you're using this ED80 for visual, but we're not using it for visual, are we? So I am going to take the camera off of the dovetail because we don't need this dovetail anymore. It's just in our way. So we're just going to hook the camera straight up to the telescope. How are we going to do that? I'm going to show you. Got to get this off here first. And simply just unscrew it. My big old fat fingers just don't get down in these tiny little places real well. I need to bring a coin up here and just use a coin. All right, there we go. So what we do is we have this snazzy little device right here. If you take your lens off your camera and look at the back of the lens of the camera, those two pieces look exactly the same. This is called a T-ring right here, okay? This is a T-ring, and it is exactly the same thing that's back on the back of this camera lens. What do we do with it? This little thing right here slides into here, right? So it attaches to the telescope. This screws onto here, just like that. And now this goes onto here, just like a camera lens does. And now we have turned this telescope into a camera lens, just like that. And we're going to need extension tubes to do astrophotography. That's exactly right. Because you have to have 2 extension tubes that come with the ED80 to put on here. Now, you get used to this. You're going to take pictures. You're going to find out some of the stars on the edges are curved a little bit. How do you fix that? There's a device for that too. Very similar to what we just put on this camera, except that it's called a field flattener. You get stars on the corners because the curvature of the glass on the back side of the telescope coming out, the light coming out of the back of the telescope has a curved wavefront. It's a very simple matter to simply get this device, like I said, called a field flattener, and we're going to take that T-ring we just used to hook onto that snoot, unscrew it, just like that. Nice long thread so it can't unscrew easily. And now we're going to screw this field flattener on. It is over in the carousel. It's the... Is it not? No. Oh, well, maybe it'll show up in the carousel here in a minute. It's the SKU, Paul, is ES-FF, ES-FF2, F5/F7. It'll show up in the carousel here in just a minute. So as you can see, now this hooks onto here, just like that. Put it in, tighten it down. You now have a field flattener that's going to make that curved wavefront flatten out because you have curved light, right? Curved light coming in, and when it hits the glass surface of the sensor, it smears on the edges. But that field flattener curves that light so when it gets to the distance it's supposed to be 55 millimeters behind it, the light's flat. Well, as it goes past it, it keeps curving, it'll curve back on itself. But now we've attached our camera to the telescope, and we are ready to start using the telescope as a big old camera lens. Now, with this, we're going to be taking, nice wide field astrophotography with it. But you start doing wide stuff and work yourself into deeper and deeper stuff. We're going to use your tablet as a go-to device. Off it goes, and you just make the tablet go where you want it to go. That's all there is to it. That's all right. We're going to wrap it up, Noah. So we'll get the field flattener on there, or go to the Amazon store and search for Explore Scientific Field Flattener. Go to the Explore Scientific store and search for field flattener. It's going to pop up. That's how you can hook your camera up to your telephoto, to your camera lens, and turn it into a telephoto lens. I'm going to go ahead and wrap the show up for today. This is how you get started in astrophotography. Start building your kit. You got a DSLR, go out with a tripod, start doing it. Learn how to manipulate it. Start working your way up with a go-to, with a new camera lens, with a bigger lens, with a telephoto lens. Start working your way up, building your kit, building your skills. On behalf of Paul Newton, who's been here remotely all week, in for today, and who's the director, gaffer, lighting technician, you name it, he does it in here, and he does a great job. Noah Menard does a great job keeping the marketplace stuff up and running. And everyone else here at Explore Scientific, we hope you have a great weekend. Bye-bye, everybody.